Hello, everyone, and welcome to today's webinar. My name is Jennifer Caveney, and I will be moderating today's presentation. All right, so let's go ahead and get started. Our speaker today is Leo Schilling. Leo is the Manager of Laboratory Operations for testing services focused on mycotoxins and veterinary drugs in food and feed matrices. In this role, Leo oversees the day-to-day operations of the laboratory, ensuring the highest standards of accuracy and efficiency in testing. Additionally, he also serves as an externally focused senior technical expert for the animal health market. To kick things off today, we are going to start with a poll for the group. So, what are mycotoxins? Perfect. All right, Leo, whenever you're ready.
All right, thank you, Jennifer, and good morning, everyone. Thanks again for coming to today's webinar. Mycotoxins are toxic metabolites produced by certain fungi and molds that can contaminate agricultural commodities during growth, just kind of like we just reviewed with this question that we started off with. They can affect different stages, as I mentioned, during growth and harvesting and storage. Mycotoxins can grow under warm and humid conditions with these commodities, mostly affected commodities include cereals and grains like corn, sorghum, wheat and rice, oil seeds, nuts, dried fruit, apples, and even coffee bean and spices. In this segment, we just defined what mycotoxins are. They're secondary metabolites produced by certain fungi in warm and humid environments. And contamination can occur at any stage of production, whether it's before or after harvest. The process of mycotoxin contamination can be mitigated in 4 different stages. Fungal growth, the growth stage, the mycotoxin producing fungi colonize organic matter such as grain and nuts or legumes where conditions are favorable. There's also a stress response where the fungi produce mycotoxins as a defense mechanism or in response to environmental stress, including competition with other microbes. There's also contamination. This is where those fungi have produced the mycotoxins, which accumulate in crops during growth, storage, and processing, often surviving food processing steps due to their chemical stability. And finally, the final stage is exposure, where humans and animals can be exposed to mycotoxins through contaminated food or feed, leading to potential health risks. Key types of aflatoxins, or some of the most commonly tested at least, include aflatoxins, ochratoxin A, deoxynivalenol or DON or vomitoxin, T2, HT2 toxins, and zearalenone. These compounds are generally under conducive and under environmental conditions where crop growth and storage, contaminating products such as grains, nuts, dried fruits, and coffee, as we just mentioned. Today's discussion will cover where and how these toxins emerge throughout the food production chain, setting the stage for understanding why proactive detection and mitigation are vital. Today's session on mycotoxins brings together the topics of food safety, risk management, and regulatory affairs. I'll discuss both the science and the practical applications of mycotoxin control, beginning by underscoring the current global importance of tackling mycotoxins, a challenge that affects food safety, public health, and economic stability worldwide. And this next section is focused on the risks associated with mycotoxins and why awareness is critical to your product safety. So why is mycotoxins testing important? They pose serious health risks ranging from acute poisoning to chronic disease. For instance, aflatoxins are known carcinogens and they lead to liver cancer with prolonged consumption, even at low doses. While short-term exposures may induce liver failure, just also gastrointestinal distress and immune response suppression. Particularly in more vulnerable populations, infants, the elderly, and immune-compromised individuals, mycotoxins are a considerable risk when evaluating your product's safety and value. Mycotoxins pose a specific health risk to humans and animals, with potential adverse effects ranging from neurological impairment to liver, kidney, or heart failure. Mycotoxin contamination in food, livestock feed, and agricultural commodities can lead to adverse health effects for both humans and animals, compromising food safety and the overall quality of plant and protein agricultural products. For example, the milk from a cow fed contaminated grain with aflatoxins can have toxic effects of aflatoxin M1 in the milk product. Since aflatoxins are chemically stable, as we previously mentioned, they can survive food processing steps, making prevention and monitoring critical for maintaining your product's food safety. Beyond human health, the economic implications of mycotoxin contamination are significant. Food producers and manufacturers face costly recalls, reputational damage, and losses resulting from rejected shipments due to non-compliance with regulatory limits. International trade is equally affected as stringent import and export standards demand rigorous testing and certification. The USDA reports have noted that financial losses can ripple throughout the supply chain, urging stakeholders to adopt robust risk management and quality control practices. In this next section, we're just going to be talking about how mycotoxins can be monitored by implementing rigorous sampling processes and detecting various analytical techniques. Some of the most effective methods include chromatographic and immunological techniques, and these methods help to ensure that food and feed remain safe for consumption and meet those regulatory standards. First, just going to be talking a little bit about methods here. Accurate and timely detection is the cornerstone for managing mycotoxin risks. Laboratories routinely employ sophisticated analytical techniques such as liquid chromatography tandem mass spectrometry, or LCMS-MS, high performance liquid chromatography, or with a fluorescence detection, and enzyme linked immunosorbent assays, or ELISA, for a rapid and low cost testing. Many of you are familiar with that ELISA format from all those COVID tests that we took back in 2020. Additionally, other rapid field tests have been developed, providing preliminary screening results that can guide for further analysis. And the FDA's transition to multi-myco testing strategy exemplifies the process and progress in laboratory practices, enhancing the overall efficiency and the accuracy and selectivity of modern detection methods. Regular monitoring protocols are fundamental to ensuring that food products remain safe within mycotoxin thresholds. This involves systematic sampling along with the food production and supply chain, coupled with continuous laboratory testing. Regulatory agencies at the domestic and international levels, including the FDA, EFSA, and USDA, play a central role by establishing minimum tolerance limits, surveillance programs, and reviewing incidence data and issuing alerts when contamination levels exceed safe limits. Such coordinated efforts help to improve potential hazards before they reach those customers. Mitigation strategies can help mycotoxin contamination in food and feed. These strategies fall into three main categories that we'll review next. One is pre-harvest strategies, and then post-harvest strategies, of course, and then finally detoxification strategies. Mitigating mycotoxin risks begins before the harvest. Agricultural best practices, including crop rotation, optimized irrigation, and pest management, can significantly reduce fungal infestation. The use of resistant crop varieties, as endorsed by the USDA research, provides an additional safeguard, minimizing the chances of fungal invasion that could lead to mycotoxin production. Integrated pest management strategies, supported by the WHO guidelines, further underscores the importance of proactive measures during crop development. Once crops are harvested, proper handling and storage are critical. Most harvest controls include rapid and efficient drying, controlled storage conditions, which would include low humidity and regulated temperature if possible, and careful handling to prevent physical damage that might promote fungal growth. Additionally, various treatments ranging from the application of chemical preservatives to advanced sorting technologies help remove or neutralize contaminated batches. The FDA highlights many of these measures in their updates to ensure compliance and reinforcing the value of post-harvest interventions. So detoxification strategies, very important consideration, as it's sometimes impossible or very difficult to control mycotoxin contamination. So there are different techniques to deal with this issue. So detoxification strategies for mycotoxins aim to reduce or eliminate their toxic effects on food and feed. These strategies fall into these three categories. So first, we have physical detoxification, where you have sorting and cleaning, as I previously mentioned. So removing visibly contaminated grains reduces mycotoxin levels, as the microorganisms typically have a single point of origin. And by eliminating those damaged kernels or parts of that crop can reduce the contamination throughout the entire lot. There's also heat treatment. Some mycotoxins degrade at high temperatures, though some remain stable. Adsorption techniques using activated charcoal or clay-based binders can trap mycotoxins and prevent absorption in animals. It's also next category is chemical detoxification. So ozonation is one method that can allow ozone gas to break down mycotoxins into non-toxic compounds. Organic acids like citric acid and lactic acid can be used to help degrade certain mycotoxins. There are also alkaline treatments. Some mycotoxins can be neutralized with these alkaline solutions. Finally, a third category is biological detoxification. So there's microbial degradation. So certain bacteria and fungi, such as lactobacillus and triderma, can break down mycotoxins. There's also enzymatic detoxification. So enzymes like lactase and peroxidase can degrade mycotoxins into harmless compounds as well. Finally, biofilms. So some microorganisms form biofilms that trap and degrade mycotoxins. Next, we'll just talk briefly about the regulatory framework. So mycotoxins are regulated on a global scale. International bodies like the Codex Alimentarius, and developed in conjunction with the WHO and FAO, set maximum tolerance allowable levels for various mycotoxins in food products. These standards enable safer trade practices by ensuring exporters and importers adhere to harmonized safety thresholds. The EFSA, for example, provides scientific opinions that guide these international standards, helping to balance risk mitigation with trade facilitation. Domestically, each market enforces its own stringent regulations to safeguard public health. In the United States, the FDA's monitoring programs set action and advisory levels for mycotoxins and undertake routine checks on both domestic and imported goods. Similarly, in Europe, the EFSA's risk assessments form the basis for regulatory limits that food businesses must meet, and quality control personnel must remain abreast of these updates and implement robust in-house testing procedures to ensure compliance. All right, next we have another section just discussing emerging mycotoxins and some case studies. So, the dynamic nature of fungal biology means that there are going to be new mycotoxins that are continually being identified. And recent studies have spotlighted compounds such as adenitis and bovaricin and alternaria as emerging risks. Climate change, by altering temperature and humidity profiles, is creating new opportunities for uncommon fungal species to proliferate. And these developments call for revisiting traditional risk models and updating detection methods to encompass these novel threats. Through data on emerging mycotoxins, investigation, we are finding that it is limited. But with some preliminary research, there is suggestion that there's potential chronic health risks and unforeseen economic impacts. Their presence, especially if they survive rigorous processing, could lead to long-term health implications and trade barriers. Regulation agencies are emphasizing the need for further research to fully understand these impacts, ensuring that future regulations remain adaptive and effective. Ongoing research projects, often co-funded by governmental agencies and academic institutions, are focusing on the evolution, detection, and control of emerging mycotoxins. Innovations include the improvement of multi-mycotoxin detection platforms and the integration of digital agriculture tools such as IoT sensors and remote monitoring for real-time assessments. These developments signal a promising future where both pre and post-harvest interventions can be optimized to address emerging risks effectively. Just to give you a few examples, these are just a couple of real-world examples to highlight how proactive mycotoxin management saves both lives and capital. In one notable instance, a U.S. peanut processing facility integrated advanced sorting algorithms with rigorous ELISA testing, which drastically reduced aflatoxin levels and regaining market trust. Another case study on mycotoxin contamination mitigation in bulk soybeans highlights the importance of logistics and food safety measures in global commodity flows. In this example, quality management sampling protocols for laboratory testing were essential in monitoring and preventing contamination during transportation and storage. One effective strategy involved real-time monitoring of environmental conditions in storage facilities. So by maintaining optimal humidity and temperature levels, the risk of fungal growth and mycotoxin production was significantly reduced. Additionally, biocontrol agents were used to suppress fungal contamination, providing a natural and sustainable approach to mycotoxin mitigation. Also, just continuous monitoring, these are some best practices, and, just drawing from past successes and some lessons learned. Some of these best practices include rigorous supply audits. So you'll want to make sure that there are regular inspections and in-process testing of all new raw materials and new vendors, and even just your regular suppliers as well. Continuous monitoring, and so you want to make sure that you have implemented some in-process testing and validation at critical stages of production. Staff training is critical. Keeping quality control teams updated on the latest detection methods and regulatory requirements is helpful. Finally, integrated management systems using traceability tools and blockchain technology for full supply chain transparency. So these practices, advocated by agencies like the USDA, FDA, ESFA, should be included in your blueprint for domestic and international food safety compliance. I mentioned training, but for a food production facility personnel, it's essential to maintain food safety, efficiency, and compliance with regulations. So just wanted to review some critical points of value. Food safety and hygiene, so employees must understand good manufacturing processes, proper hand washing, sanitation, and personal hygiene to prevent contamination. There's also hazard analysis and critical control points, or HACCP. Training on HACCP principles ensures that workers can identify and control potential food safety hazards. And regulatory compliance should be a critical concern and should be discussed regularly with employees so that they're trained on Food Safety Modernization Act requirements and other local regulations to ensure compliance. Equipment handling and maintenance, proper training on machinery operation and maintenance reduces downtime and enhances productivity and safety. Finally, another one that isn't really highlighted often, in relation to contamination, should be emergency response and crisis management. So even during those instances where we are off our regular process, employees should be prepared to handle food recalls, contamination incidences, and other emergencies. We're now going to just open the floor to your questions, whether you wish to discuss some specific detection challenges or share some experiences from the field or seek clarification on regulatory nuances. I'll address your concerns, drawing on case studies and practical examples that reflect international and domestic experiences. This is an interactive segment, so it's designed to foster, kind of a deeper understanding of how you implement these strategies effectively within your own operations with insights drawn from the USDA, WHO, and FDA and others. I do see some questions, but Jennifer, you want to help out here with us checking out what's in the chat.
Yeah, let's grab a couple of questions from the chat. All right, so here's the first one. Two different labs tested a lot of my product and got vastly different results for mycotoxins. Do you have any thoughts on on why that might be?
That's a great question. So as I mentioned earlier, with mycotoxins, because they are metabolites produced from fungi, there's going to be a single point of origin. So depending on the distribution of those toxins and how many points of origin there are in your contaminated product or your lot, the results can definitely vary. Even within laboratory, test portions, there can be difference in the results. So it's actually not very surprising, to hear that you've had issues with, between different laboratories, providing you with different results. And so since the homogeneity or distributional heterogeneity is really probably a better way of thinking about it, since we can't really mix those very well, we just do our best to kind of get them as uniform as possible. But just the nature of the distribution of those toxins in the product makes it very, very difficult to sample. Routines for collecting laboratory samples should be a part of your protocol, so that process is very consistent. Communicating with the laboratories to make sure that you have sent an adequately large test portion so that it's representative of the larger lot. And making sure that the laboratory that's servicing your testing is, mixing your product appropriately, and taking a large enough test portion. So that's kind of one caveat that a lot of labs might fall into is taking too small of a test portion, not allowing a large enough sample to take on the amount of contamination in there and get a good representative number. But it's not uncommon, essentially. So that's a great question.
Perfect, thank you. All right, we have another one in the chat. How can mycotoxin content change over time post-harvest?
Another great question. Our laboratory actually retains samples for anywhere from 30 to 90 days or longer, depending on some cases. And in those times, if you just kind of reflect back on some earlier slides, as I mentioned, we do have the issue of microbial contamination going on in that sample. If there is going to be a positive hit for any of those mycotoxins, it's very likely that those microbes, those fungi, are still in that sample. So if we set that sample on the shelf and we come back to it in 2 weeks, if there's a sufficient amount of moisture and heat, in that sample, in the bag of sample that we have on hand, it is possible that those results could increase. In fact, it's very likely they would increase if there's still fungal contamination in there. On the flip side of that, I mentioned with the previous question actually that the distribution is not even. Even when we do our best to in the laboratory side to make sure that we've mixed the sample, there are still hotspots. So even a second test, sometimes we might have a client who would request a retest because they receive a result that's out of specification. It could go either way. We could go back and grab that sample and get a higher result, due to potentially more contamination from those the fungi. Alternatively, if the sample is not, if we happen to get a spot that is not as hot as the previous test portion, you can actually get a result that's lower. So it is really kind of difficult to get a reproducible answer, and really kind of the best way to handle those situations is retesting and replicate.
All right, awesome, thank you. I think looks like we're caught up on questions here.
We're going to move on to some future perspectives. Just a couple more comments before we wrap up today. You just don't want to ignore these. There is a lot of technology, entering industry. And so as we advance, these emerging technologies such as, Internet of Things or IoT-driven storage monitoring and blockchain-enabled traceability are poised to further refine mycotoxin risk management. Future webinars might explore these innovations in depth, explaining how digital transformation can create even more robust safety nets. So stay tuned for discussions that continue to bridge scientific research with operational excellence in food safety. And finally, just a couple of closing remarks. Just want to review the things that we talked about today. So just to summarize, today's webinar has taken us through a comprehensive introduction to mycotoxins. It's just an introduction, plenty more to go. But their definition and the sources of the risks and they pose and the modern strategies applied to detect, monitor, and mitigate them. We also reviewed some best practices and examined regulatory frameworks that safeguard food safety, emphasizing the collaborative efforts required across global, national, and industry levels. I also want to encourage you to connect with us. So if you'd like to reach out, you can scan this QR code that can take you to our website. Always can reach out to info@eurofins.com for information on upcoming webinars, so that we can kind of discuss and ways that we can support your facility. And finally, thank you, for being an engaged audience. I hope that we leave you with not only a better understanding of the challenges posed by mycotoxins, but also practical strategies to combat them. Please look out for upcoming webinars, as I mentioned, and additional downloadable resources, that will further your expertise in food safety management. And your participation is key to creating a safer global food supply. And we encourage you to continue ongoing dialogue and collaboration in this critical field. And toward that, we will be releasing some infographics and things like that that are helpful, that might be useful for you to share with colleagues and customers, things of that nature. So please do connect with me on LinkedIn. You can scan this QR code, and I look forward to connecting with you. Thanks again for joining us.
Great, thank you so much, Leo, for today's presentation. I just want to extend a thank you to everyone who attended. As Leo mentioned, please reach out with any questions and we would be happy to connect further to discuss this important topic. This now will conclude today's presentation, and everyone have a wonderful day.